In this video, we are going to do remote sensing and we're going to apply supervised classification. First, add your composite bands. Okay, it's the image that you combined all the bands together. I'm going to double click on this, go to symbology and change to combination of 7, 5, 2. And what that means, it means I'm going to give a false color to band 7. Okay, I'm going to show band 7 with that color, band 5 with green color, and band 2 with blue color. Apply and okay. This combination seems it's a good one, at least for this area so far. But we're gonna do pixel analysis to find out best combination as well. Next, we're gonna activate SPC, specific classification. If you have this ribbon, which means it's activated. If not, you can right click on this gray area and then check these two boxes. Alright, so let's say we have that one. First things you should do, you should click on this icon. It says semi-automatic classification, and click on this refresh and open up the list. So whatever you added here, okay, in the layers, it's gonna show up here. I'm gonna choose my composite image and the bands will appear here, which means we are choosing our image to work on. You can close this and keep this window here as it is. So what next, what we're gonna do is we are going to choose several pixels, okay, that they have similar colors. I recommend you to add your outcrop units. Okay, do you remember we had some points that was given as a Google Earth file? Open up that one on top of this and see, you know, which area it looks like, you know, Marquines, which area it's Ortega or Recanada and so on. Okay, but I know roughly where they are. That's why I'm not adding here for now. So next, you're gonna click on this guy here, create a new training input. Okay, because we are going to train the software, okay, to do the job for us, right? It's machine learning, part of machine learning. So let's call this one as a signature. Save. You see the file appeared here. So what I'm gonna add here, it's gonna end up to this file. So first, I see this orangish color, like orange red. It's quite, you know, sharp. So I'm gonna start with that. You can zoom in and you can choose this icon. You see, create a ROI polygon. You can select this and try to, you know, draw 4 of them. And if you are, you know, if you are clicking the last point, right click it, so it's gonna close it. So either you can do it this way, you cannot really draw a very large one, just do the one that covers only, okay, few pixels, maybe 2, maximum 4, not more. Okay, either you can do this way or you can choose the automatic one that will choose for you. Select that one and click in one of these pixels, and it's gonna, you know, it's gonna actually choose those that they are really similar. Okay, I'm gonna do this way. So I'm choosing this area that their signatures, it's similar, and then here you're gonna set only CID and C information. I'm gonna put the ID as 1 and I'm gonna rename this as a, you know, quaternary, all right, or Q, and then I'm gonna hit this box here. All right, so now I added 1, right? This is 1 input data and my signature. So what you're gonna do, you should go across the picture and try to see, okay, similar units. For instance, this one here, it's similar, so I'm gonna do the second one here, and you should, you can click a little bit, like that, to find the best area that this extends more. I think that would be much more useful, but it's not necessary. Still, 1 pixel would be enough, right? Even though if I click here, okay, still this is fine. So I'm going to change ID to 1 and click 1 on this. Let's put this one. I want to just show you, still you see the color, it's different in our eyes, but their signature from different bands, it's very similar. That's what's taking all these three. All right, I'm trying to show you that sometimes, it's going to take only one pixel. So still is taking, more. So how about this area? Let's click on that. So let's click here. Okay, I'm going to choose this one too. So click OK. I think it would be enough, these 5. All right, and as you see, the type is B. If the type changes to, if you do, manual polygons, it might end up to B or R. If it's R, just select and get rid of it. But if you do with the automatic, polygons, then it's gonna be all fine. So let's see if we have a good coverage across the picture. So you see, I'm trying to get from different locations, maybe somewhere here. Okay, let's take that one as well. We go to that size. How about here? All right, I'm gonna take this one. And then when you are done with this all, okay, with this quaternary, okay, let's select all of it. Just click and hold and drag down to the list, and then hit this guy here, okay, merge spectral signatures, and then say yes. It's gonna merge these, okay, 7 into 1 as a merged queue. And if I do this, I don't need the others. So select all except the merged one and hit this one here, delete signatures, yes. So I have now this one, okay, as a 1 signature. So you can just click on this, one more click, and it will let you to change the name. Okay, I'm gonna change it to Q. Let's go back to this view. Next, I'm going to work on this distinguished blue color here. All right, somewhere here. And I know if you look at to the points, probably pillar, it's cropped out in this area. You can get information from there, or you can actually, if you want to do a little bit precise picking, I would add the hillshade, because the hillshade will help me to find out where I have a good outcrops, right? For instance, here, the best outcrop, it's going to be, in the wall of the valleys, right? Rather than doing at the bottom of the valleys, right? So somewhere here, probably it's good area to select. So let's see what we have here. You see, probably I would select somewhere here, which is quite bizarre, but if we wanted to select, we would select, something strong like this below here, right? So what we have, that area, it still is fine, right? Yeah, it still is good. So I will go somewhere, here. I want to remember, okay, somewhere here, it's a good area of picking my cells. So I'm going to click here, and then I will change the ID to 2, and I think this is pillar, but you can make a best decision based on the outcrops that you have, right? We already gave you the list of the outcrops in Google Earth, and you convert it to your QGIS. All right, so let's do another one somewhere here. All right, let's see if it's, yeah, I think it's a good area. I'm gonna change the ID to 2 because the ID of pillar is 2. Okay, that one done. So as you see, the blue color is just disappeared here, right? So there's no pillars here based on this image combination. So next I'm gonna go somewhere here. Okay, only 1 pixel, that is fine. Select that icon. And you're not going to, select something here, right? Because that seems very different. So stick to the same colors that you see. And later on we can make a better decision. But we go as we do now. And later I will show you what to do. Alright, I'm gonna stop here for pillar. Again, select all, combine. Delete these, don't need it because you have the merged one. And then I'm gonna rename this to pillar. So next one, we know Marquinhos, it's somewhere here, okay, in this ridge. Somewhere here, it's just one, that's fine for me. So I'm gonna do somewhere here. Marquinhos ID is 3. Maybe somewhere here. Again, when you're choosing these points, go with your guidance from KMZ file that we gave you, and you have it in your in your project. So I'm done with this. Merge it. Get rid of these 3. Rename the merged one. And next I'm going to the core. Alright, somewhere here, I see that one. The Ortega will be here. The code is 4, and this is Ortega. Maybe somewhere here. Didn't pick up anything. Okay, this one here. It's ID 4, Ortega. Maybe somewhere here. Okay, Ortega. These 3 enough. So you might do a little better job. So you need to go, from end to end and choose some signatures for different part of the image. Merge. Delete those 3 and rename the merged one to Ortega. Okay, next one. I'm going to. There is one missing, which is Ricanada, and that would be somewhere between Pilar and Ortega, right? Somewhere here. So I'm gonna go off somewhere here. I don't click on the light colors because that might be a mix with the quaternaries, right? You can choose this, or you can choose somewhere here. That might be even better. The code is 5, and this one it's click on that. Another one somewhere here. Okay, ID is 5. Maybe one more somewhere here. Again, if you have guide, use your guide and try to get off from that. Alright, somewhere here, Canada. Alright, I think it's enough for our practice. I'm going to remove this and rename this to Canada. Alright, it seems we have almost everything. I'm gonna change the colors to something that makes more sense to me. All right, I'm gonna put that one as something great. Ortega, let's put it this color. I'm just going to, put it some kind of distinguished colors. All right, so perfect. So I have those, and next you need to see, okay, what we're gonna do. We're gonna look at to the values of the bands, okay, the numbers in each band for these pixels. Okay, so how to do that? You select all of it and hit this icon here. It says, okay, add highlighted signature. Okay, click on that, and here it's going to give you the signature of different bands. So whatever you have here, you see, let's get rid of this grid for now. And you see, these are the band lines. This is band 1, 2, 3, 4, 5, 6, 7. We excluded band 8, and this is indeed, it's band 9, which is shown as a band 8 here. Alright, as you see here, there are different colors, right? And if I move this one here, now you can actually see these are the codes, right? 1, 2, 3, 4, 5 refers to this 1, 2, 3, 4, 5, right? The blue one is Ricanada, right? The red one or dark pink is Ortega. Then you have Marquines, you have Pilar, and you have the quaternary deposits. This is the signature of that. What that means, it means these rock units, okay, they have different values in different bands, right? If you put them in this graph and connect that line, that's going to give you a signature. So it seems the signature in this area, it's very similar. And don't forget that everything here is metamorphic rocks, right? It is somehow, okay, they are similar to each other, because one, it became quartzite because it was more sand in it. One became as a schist because it has more clay in it. So there is very close, chemical composition between different rocks, okay? So that's why the shape that you see is pretty similar. But one thing that is very interesting is the value of the cells in each band, okay? For instance, as you see in band 1, all right, different rocks, okay, they have different values, but the values are very close together, and it means you are not able to, distinguish very nicely. If you look at to the band 8, which is indeed our real band 9, and if you have read the PDF file, the band 9 actually covers the cloud. So it seems everywhere similar, and all of them are, collapsed in one point. So if you look at the band 8, you are not able to distinguish the rocks. But what would be the best band? It's gonna be band 6. You see, they are widely spaced, okay, and each rock has its own, distinguished values. So that's gonna be a very good band to look at to the rocks. So if you choose 3 of them, it's gonna for sure be band 5, 6, and 7, right? You see in this area, there is a wide distribution of these spectrals. So the good thing would be I can go back to this picture and double click on the composite image and go to the symbology, and now I know it's band 5, 6, and 7. If I look at this image with this combination, that's gonna give me a better clue. Okay, that's gonna give me a better clue. Maybe you can change this one to 7, 6, 5. It still is fine, but play with these 3 and try to get one which makes more sense for you. Alright, so I think this is good. If you have been in the field, you can actually say this is a very good looking satellite image for that area. I'm gonna explain you why. I know it's blurry, it's pixelized, this is what it is, and remember that we are doing very high resolution mapping, and each pixel is 30 meters by 30 meters. Alright, so let's keep this combination here, and we jump into our window here, right? We were here, and we said 5, 6, 7 is a good combination, and based on that, we change the colors there. Alright, so what we're gonna do next, you can close this. Alright, we are going to make our map. Okay, we're gonna see how the software starts to pick these outcrops. Okay, you go to classification and you say, okay, use the CID, because that is the one that we used as a 1, 2, 3, 4, 5. And this is the algorithm. Okay, minimum distance, maximum likelihood, and spectral angle mapping. So I think minimum distance is good because our picture at this scale, it's blurry, or it's pixelized, so it's better you choose this. But you can try, different algorithm and save it. And then the rest, you don't need to touch it. Click run and save. Okay, I'm gonna save as a test one. Save your file. So, alright, so here we got, okay, a simplified version of the map. This is not geology map, okay? Remember, this is it's giving you a guide to make your map, okay? You're not going to digitize these colors and say, this is my map. No, this is a kind of guide. So where you see that yellow color, for sure that is the quaternary deposits. Okay, test one. Transparency. At least for quaternary deposits works really good. So that is good one. So the next one, what you can do, okay, just try to see different algorithm. I'm gonna choose maximum likelihood, run, and name it as a test 2, or you can rename based on the algorithm that you're using. This is also interesting. Let's see. Bring this one up and look at with that. All right, I see. Okay, you see, for this one, quaternary, it doesn't really looks good. Okay, this one is better, but for maximum likelihood, it works really good for pillar, because as you noticed, okay, the pillar, it was ending somewhere here. So this is, in my opinion, it looks much more better to compare with the first one. So let's do the third one, spectral mapping, angle mapping, and run it. And let's call this one test 3. Okay, this is also very interesting. I think I like this one more because it is more close to what we see in satellite images. Yeah, let me give a little bit of transparency. You see the quaternary, it's picked up really nicely. Pillar, okay, this is pillar, and somewhere here, okay, there is a little bit outcrop there, and the rest, it's a little bit complicated. And don't forget, again, Marquinhos, Ricanada with a lot of quartzite bands, and Ortega all have more than like 80-90% of quartzite. So they're gonna show you similar signatures, but we will find out how we can distinguish those. Okay, so for now, okay, I'm giving you an idea, okay, how you can train the software to provide the map for you. And if you are doing a very good job on training portion, okay, here, then your map will look like really nice. So you need go back and forth, okay, and do better picking based on your outcrops, and you're gonna get a better map. I'm just doing, you know, for the purpose of recording, but for you, you may spend like, you know, 4 or 5 hours to go, you know, test and see which one is good, which one is bad, and then go with the good ones. And remember that you can spend one day and you can map a very large area that is impossible doing in the field. All right, so let's say this is a good one. Let's say I'm happy with that, and I'm gonna remove the other tests that I did. And I'm gonna keep this one here. And in the next videos, I'm gonna show you how you can deal with this image. But for now, okay, I will wait until you guys get into this stage with the good results, and then we can continue from there. Let me see if I have something to say on this. Let me check one more time. Maybe I click on that, add a little bit of transparency on it. All right, so I think this map will make more sense for the people who are in the field than you, so you can get help from you know, from TAs. So as you see here, okay, I told you that we know that your points here, okay, this is going to be your Ortega. So somewhere here you have Ricanada, and then somewhere down here you have Marquinez, and all of them has, you know, quartzites. If you look at this map, okay, you see this side of the hill shows the same color as this and the same color here, right? And it's exactly the same as in the field. So here you have the quartzite, here you have the quartzite band, okay, it goes all the way down here. Let's see if it's picked here. Yeah, it's a gray one, right? This one, this one, this one here, this one here, and some it's the, you know, a little bit of the pink in between, and that probably it's because it's the, you know, it got some coverage of the soil or dirt. Somewhere here again in this side you have a really good outcrop, but the other end, okay, it's covered with the fluvials, right? So and you see the pattern here, right? You see this is a fluvial deposit, but here you have the outcrop. So again, if you look at the satellite image, the one that we did, right, it looks this side much more distinguished than the other. So I think this map, this Pixelite map, it's gonna give you a very good guide how you can follow, okay, the boundary between these different outcrops, okay? So the points that you would have, okay, it's gonna be end up inside these, you know, polygons, and these, you know, colors will guide you how you can draw your boundaries, okay, or your polygons. We will get into that later on more, but I think this map, okay, it's good, at least we have really good outcrop of the pillar. We are seeing really good distinguished colors for the quaternary deposits, or maybe, you know, maybe it's a Cenozoic deposits. Never, you know, we didn't do any dating on it, but in the field it seems, you know, quite recent. And then there's a little bit of complication of distinguishing the, you know, Ricanada, Ortega, and Marquinez, and we're gonna talk about that more later on during our meetings or in another video. But I would like to do it during, you know, meetings, because we get some questions and we have some discussions there. So there is one good thing here that I would like to highlight, and that is indeed concentrate more on this valley, okay? That's something happening here, and we see it quite nicely here. So if you look at the colors in different side of the valley, right? So you're gonna see a big changes. Here you have the red, here you have the pink, here you have the gray, here you have the blue, right? Here you have these red, here you have the blue, right? So there's something going on. I know you can guess what it is. So let's look at this in details later on. All right, so I'm gonna stop my recording here, and again, what I have done here, it was a quick job to show you how you do the process, but it's your own responsibility and work to choose best locations to come up with a good training plan and get a good guide map like this.